Hey folks, I think we'll get started. This talk is about blending 2D and 3D worlds. The project is very interesting. It has a technical breakdown of how he has achieved this blending of 2D and 3D worlds. Welcome Supanta, and have a great talk. Yeah.
Is this working? Is, this is not a name, right? Is it? Okay. All right, folks. Thanks for coming. I know we're all looking forward to having lunch, so I'm gonna zoom through this really quick. My name is Supantha Paul, and this is about the technical art or the technical breakdown of creating seamless hybrid 2D 3D worlds. What that means, we'll get to know in a second. I'll just quickly introduce myself, and the clicker is not working. It is connected, yeah. I'll just, oh, okay, now it's working. All right. So I currently work as a software engineer at an MNC, but I've been into game dev for the better part of my life. And I freelanced as a Unity developer for some VR mobile games. Sometimes I make some tools for Unity. The 2D platformer controller, I have actually seen some of you guys use it in one of the IGDC game jams. So that was pretty cool. And recently, for the last 2 years, I've been building my game called Abashed. It's a narrative-driven game about a man who's suffering with a rare mental disorder, and the story is about him trying to find his missing partner, and in the process, finding himself. So if you like games like Inside, Little Nightmares, this game will be right up in your alley. You can check it out on Steam. It's releasing next year. And I use a very specific art style for this game, and which is the topic of this talk. So, all right, no, I guess no. I have to be close to it? Okay, apparently. So I'll just play the trailer for you guys so you know what I'm talking about. There's no audio, it seems. All right. All right, that's a bash for you. And as you just saw, I use a blend of 2D and 3D graphics in this, and we're just going to break down just that. First of all, how many of you are from a technical background, like programmers? All right. And how many of you are creatives, like artists? Okay. A lot of people are both programmers and artists. It's very sus. Um, so we'll break down what is HD2D, a brief analysis, and few of the games using it. And then we'll go over the technical breakdown of how you can achieve it for your own games. We'll go over some scripting, some shaders with Shader Graph, and overall art direction, and how to work around the limitations of this. And all my examples are in Unity, but I tried to make this as engine agnostic as possible. So whatever engine you're using, you should be fine. Right, so the emerging 2D and 3D art style in games. So for the past half a decade, there has been more games which are experimenting and trying out having 2D pixel art elements as characters or other dynamic objects, and the world around them will be 3D, basically the static parts, right? The most popular example being Octopath Traveler. This is the game that really popularized and mainstreamed this art style. And then there's Until Then, beautiful game. If you haven't played it, try it out. And The Last Night. I think this game was announced more than 6 years ago at E3. And since then, there has been no news. It's not been cancelled. The developers are working on it, but no news about release or anything. If this game comes before GTA 6, I'll not be surprised. Right, so let's talk about the term itself, HD2D. So by definition, it's an art style that blends dynamic 3D backgrounds with 2D pixel sprites, creating kind of an intersection between old gen and new gen graphics, right? And the term was first coined with the popularity of Octopath Traveler, but that doesn't mean that game invented it. It's been there for a very long time. And it appeals to both old and new gamers. What I mean by that is, you guys are not old, but pixel art is always going to have a certain charm. It's never going to die, but you may not have the same reaction to pixel art if you don't have the nostalgia of which the gamers from the older generations do. So what this art style aims to do is kind of a bridge between both old gen and new gen graphics so that it appeals to both old and new gamers, right? And some observations. So all these games that I just showed you, for all these games, the pixel density or the resolution of all the 3D models and the textures that they use roughly matches the pixel density or the resolution of the 2D sprites that they use, right? And these games tend to use real-time lights a lot more than other games, partly because if you just slap a 2D sprite on a 3D world, it's going to look very out of place. So that dynamic lighting and that 2D sprites interacting with that dynamic lighting kind of bridges the gap between the 2D and the 3D aspect of it, right? And they also very heavily use post-processing to hide the shortcomings of this art style. For example, since we are using pixel textures for our 3D models as well, when you view them from a distance, they look very distorted and very heavily anti-aliased, right? So a lot of games using this try to hide it. For example, Octopath Traveler tries to hide it literally by using very heavy depth of field for things in the distance. And similarly, Until Then tries to use a lot of volumetric fog to hide things in the distance. And yeah, and this seems to work best with the side-scrolling POV with the games that I've analyzed. Right. So we know what 2D HD is. But it's not a new affair, however. Paper Mario for the Nintendo 64 did it all the way back in 2000. Even though it's not pixel graphics, so it doesn't really qualify as HD 2D by definition, but yeah, still it's 2D and 3D, right? And they recently also had a remake for Nintendo Switch. And I wanted to mention some more non-pixel art examples. Born of Bread, Outbound Ghost. Both of these, as you can see, also heavily use real-time lights to make the pixel sprites or the 2D sprites look good in a 3D world, right? All right, so let's go around implementing this. So if we just come to a prototype environment and slap a 2D unlit sprite in a 3D world, it's going to look very out of place, right? It almost looks like it floats. It doesn't interact with any of the 3D lights. Very bad. And we can very easily enable 3D shadows. Most modern engines allow 3D shadows with 2D sprites. If you use Unity or Unreal, it's as simple as a toggle. And if you use Godot, you'll have to use the sprite 3D node instead of the sprite 2D node. Right, so still we don't have lights interacting with it. So we can make a very simple lit material, just have the main texture connected to the base color with shader graph or whatever material editor you use. And this is how it's going to look. In most cases, your sprite is going to be very dark. because since it's a one-way flat plane, if the lights are not directly in front of the sprite itself, it's not going to affect the sprite in a meaningful way. So we need a way around that. So what we can do is, since we already have the base color, the main texture, we can use that main texture itself as a emissive map for the sprite. So that's how it would look in a shader graph. So we have the main texture, the sprite itself, and then we multiply it with a emissive color, and then connect it to the emission node. And this emission color, you need to make it very dark gray, so it's not overly emissive. And the result of that would be your sprite being somewhat lit always, even if you're in a completely dark room. But it's also going to be affected by 3D lights, right? Now we could leave it at this, but when I tried it in my own environments, indoor or outdoor, the sprite still felt a lot flat. Even if the lights are in front of it, the way the lights interact with the flat plane, it just looks like a flat image, right? So what some of the games I mentioned before does is implement something called edge lighting. So by definition, edge lighting means the edges of your sprite will be more sensitive to light and will bright up more than other parts of your sprite. So in this case, if we see the character is very close to a light, so the back of his head and the back of his hand kind of illuminates more than the other parts of his body. And this really makes the sprite look more grounded to the 3D environment. Right. So how do we implement it? So we could edit the shader we had just made. We could create a mask for just the edges, and then use that mask to illuminate the edges of the sprite more. But since if you do this in a shader graph way, and depending on the platform you're building for, doing that every frame dynamically, especially with changing animations, it can cost a lot of rendering power. And if you have a lot of characters, this can really, bump down your FPS. So the better way of doing this would be to use a normal map. So for a sprite like this, if we create a normal map that encodes slope direction towards the edges of your sprite, the lights will bounce off those edges directly towards the camera, so it will feel like there is edge lighting. It will simulate edge lighting in sort of way. So how do we make this custom normal map for just our purpose, right? To do this, we need to learn a bit more about normal maps. I'm sure you all know what normal maps are, but we'll go a bit in depth. So normal maps encode surface detail information with colors. There are two main types of normal maps, the OpenGL style, which Unity or Godot uses, or the DirectX style that Unreal uses, right? Unreal tries to be different in every way, right? And if you look at the color, I'm just going to go with the OpenGL style from now on because all my examples are in Unity, but the only difference between y-axis of colors are flipped. So if you do it my way and then just flip the y direction for the colors, it would be the same. So the color, each pixel in a normal map will correspond to the direction of that corresponding pixel on the surface. So it will take the color, and for that pixel, it will calculate the normal direction for you. And green means how much that particular sprite is facing up. Red means how much that particular pixel is facing right. And blue mean how much that the pixel is facing forward. And if you see the normal map color wheel, the color all the way at the center, that would be halfway green, halfway red, and all the way blue. And this would indicate a flat surface. And if you have normal vectors, you can easily convert them to normal map colors using an algorithm which we'll see later. So with this information, we could literally just pick colors from this normal map color wheel and then just draw our normal map, right? You can see the top of his head are green, the right part is red, so we could just use these normal map colors to really draw our normal map. But if you're using sprite sheet-based animation, which in case of pixel art you probably are, and you'll have multiple animations, so your whoever is your artist is really going to hate you if you tell them to draw normal maps for all the frames of your sprite, right? So more efficient way of doing this would be to write a script because the algorithm is right in front of us. If we could just take an image, do some processing, and then output our custom normal map for edge lighting, that would be really cool, right? So we could write a C++ or a Python script. We could write a Unity editor script. But the most easiest way for doing this would be to write a sprite script. If you don't know what this program is, it's a pixel art editor program. Those of you who draw pixel art would know what this is. And very cool thing about Sprite is it lets you write scripts in Lua, and that script will have access to your current image in the canvas, and you can loop through all the pixels and do whatever you want with it, right? So that Lua script would look something like this. So you will get access to your cell, you can get the image that's there in that cell, and very easily you can loop through all the pixels. And since it's a pixel art image, the resolution is probably going to be very low. So looping through the whole image is not going to be a problem. And we can get the XY of that pixel and also the RGBA color. And this would be enough information for us to do an edge detection algorithm kind of general map for our edges, right? So the edge detection, or more like calculating the normal vector for the edges, would look something like this. So I'll have a pixel, and one pixel will have 8 adjacent pixels next to it, and I just go through all the 8 adjacent pixels and check if that pixel is transparent or not. And based on that, I give that particular pixel a x direction and a y direction, which will later use as a normal vector, and then we'll convert that to a normal color. So that's how it looks. So the red pixel on the left, let's say we are currently processing that. We can see the top, bottom, the right, top right and bottom right pixels are transparent, and the other adjacent pixels are not transparent. With this information, we give it a normal direction for the right. So x would be 1, and then y would be 0, right? And similarly, for the red pixel on the right, you'll see there's one adjacent pixel in the bottom that's not transparent, and with this information, we kind of give it the normal direction of top right. Right, so we have the normal direction for each pixel in our canvas. And with this normal direction, we just have to normalize it, because we'll, in the edge direction algorithm we just showed, we do a lot of addition, subtraction on the normal direction. So we'll have to normalize that. And then we can invert the y if we are going for a DirectX normal map. Or if not, you can just leave it like that. And once we have the normalized normal vector, that is the algorithm to convert that to a normal color. We basically just have to multiply with half, and then add half, and then multiply with 255 for each of these RGB, and for the alpha it's going to be 255, right? One thing to note, if you have semi-transparent sprites, it's not going to behave very well with this script. You're going to have to do some more processing for uh, with alpha values between 0 to 255, right? So with this, we have generated the script, and if you feed it an walk cycle or any animation like this, it will generate and give you your custom normal map with just edges in the slope, right? And this is kind of the before and after of not using edge normals and then using edge normals. You can see how the light behaves, where the left looks like a piece of plastic, the right has a bit of depth. And this is an extreme example, but if you use this and you're going past some light, or there's a light source above you, it really gives you that dynamic lighting feeling, which you get in 3D objects often. Right, so with this, our character is good to go. So some of the games I mentioned before, they use a different kind of edge normals. Until then uses edge normals similar to this, but October Traveler kind of creates ovals for normals for each part of their body to give each part of their body a certain definition. And with my research, I found out for Octobar Traveler, the normal maps are actually hand-drawn, and most of those artists probably left after the game launch. Right, so we are done with the character. Let's see what we have to do with the environment to make it look good with the character we just made. So, like I mentioned before also, all the textures and materials that you use in your 3D models, they should roughly match the pixel density of your character to make it seem cohesive with the environment. Because in the background, if you put a 4K texture of concrete and in front you have a 32 by 32 sprite, it's gonna look really out of place, right? And for 3D models, it's not that simple because for certain models, your UV is going to be very complicated and it's going to be hard for you to know what should be the texture size to make sure the front facing portion of my model has the same pixel density as my character, right? So the method I use for this is to define a PPU or pixels per unit where the unit will be decided by you based on your game scale, right? So an example of this in my game, since I'm using real world units for my game, it was easier, but if you use stylized units, it's gonna depend on how you wanna scale your player with respect to whatever environment you chose. So for me, in the PPU, the unit is 3.5 meters or 3.5 Unity units because Unity units are also meters. Um, so for per 3.5 meters, I have 128 pixels. So using this fixed formula, I can know before creating the texture and before even unwrapping the model to decide how much, which face, how much pixels to put for what face, right? So for example, the photo frame there, I know for just the photo part, I would need somewhere around 96 pixels horizontally, right? Some games do it more, make it more complicated, the PPU system. Some games seem to put a distance multiplier on it. So for example, in Until Then, things that needs your attention in the distance seem to be more pixelated than things in the front. This is to make sure it still feels, like I said, if you put highly pixelated models in the far back, it's going to look very anti-aliased and you're not going to be able to read or see what's going on. So the posters in the far back, they use a very lower resolution font than posters in the front. But it can get really complicated really quickly because if you make a model for a distance object and then later you want to reuse it for something in the foreground, it's going to be, you'll have to retexture it basically. So now we know we need to pixelate our textures, but if you're going with the PBR workflow, like hand drawing all the maps can be really difficult. So we can create a shader to sort of pixelate it on runtime, right? So that's as simple as a pixelation shader gets. You take the UV, you make a float a pixelation value based on how much you want to pixelate it. You multiply that with the UV, you floor it, and then you multiply the result of that floor, you divide it with the original pixelation value. What this essentially does is divides your UVs in chunks, where each chunk will only have one color associated with it. So it's not really pixelating your texture, but it's kind of simulating that by chunking your UVs, right? And one problem with this is your textures will have to be square for it to work. If you have texture for a poster or a carpet which is long in some direction, the blocks are not going to be square, right? Because we are doing the same thing for each axis here. To fix that, we can accept any aspect ratio with just complicating the shader a little more. So the only difference between this and the previous one is we're also accepting a resolution parameter, which is a vector 2, where you would feed the resolution of whatever image or texture you're trying to pixelate. So if I have a poster, if I have a horizontal poster, which is 256 by 128, this will, and feed it in the resolution parameter, this will create more blocks in that axis than the other axis. So the result of that pixelation will also have, chunky blocks, the square ones. And this is the result of how it works. So I'm changing the pixelation value on runtime. and taking a high-res image and then pixelating it and making it a pixel image, right? And I'm going to do it with another image. So for the wood texture, it worked out really nice. This pixelated wood texture is actually usable. But like you saw with the brick one, if you have a lot of detail in your high-res texture, it's not able to retain that structure in your pixelated version. And that can really take away from your artistic control. So what I did for my game is hand draw all the base colors, all the base main textures, and use the pixelation method for the secondary maps. Like you can pixelate the normal map with this, create a sub shader or a subgraph out of this pixelation method we just saw, and then pass all your secondary maps through that, be it roughness or normal ambient occlusion, everything. And you can create a fully PBR pixelated material for all your game world. And where this shader also shines is VFX. So I had to make a fire shader for a fireplace. So I made a simple fire shader, and that would be a high-res shader. And I simply used the subgraph that we built, the pixelation one, and then just passed in the original AV and then used the pixelated UV for the rest of the graph. And that's how I made a pixelated fire, right? And I use this for all the VFX in this game, be it fire, be it some particles, even the darkness you saw coming in the trailer, that is also pixelated. I don't know how visible that is, but it had to match the density of the wall textures or the player, right? So that's it. We have achieved pixelation and cohesiveness on both the character and the environment. So if you bring these two together now, it's going to look just the way like Until Then or the other games do it, right? And I'd just like to end it with assembling a very simple HD 2D scene with you guys. So it's going to be a dreamy outdoor environment. So I added a simple terrain with some default Unity fog. I put one primary directional light and the player itself, right? Pretty bland now. And one thing you need to mention, like I said before also, shadows and dynamic lighting is key for this art style. So how you place your lights is going to be very crucial. You need to make sure the shadows of your player and the way it interacts with the light is very visible and in your face, right? So I thought the player is a little still a bit less visible. So I added a secondary direction light, which is only for the player layer. And I pointed it at an angle so that some of that edge lighting in the back is visible. So it'll feel like it's kind of getting illuminated from the primary sun source, right? And then I didn't pixelate the ground texture because it's going to be covered with grass anyways. And I made sure that the pixel density of the grass also matches the player. So whatever strand you create and how you scale it in the terrain kind of depends on how you do it. And you add some more terrain details, whatever, trees, flowers, whatever you like. And like I mentioned before also, once the pixelated textures goes in the far away from the camera, they kind of look like spikes and very anti-aliased, and we don't want that. So we're going to solve it the Until Then way with volumetric fog. So things in the distance will just go away. We're going to hide whatever doesn't look good, right? And we add some things in the distance to give it a bit more depth to the environment. And after adding the volumetric fog, I felt like the grass looked very dull. So I made a custom grass shader that implements translucency, some custom ambient occlusion, and some vertex deform, which basically takes in a global noise texture and deforms the vertices over time so that it looks like the grass is affected by the wind. And we do some post-processing, and that is how it turns out. Of course, if you're making endo scene, it would be 20 steps instead of 8 steps, because you'll have to be really careful with how you place your lights to make sure your player looks not like a piece of plastic, right? And yeah, with this, we have achieved this style. The whole point of me doing this is to promote this art style. I think there's a lot of room for improvement and a lot of room for innovation, because for the games I have mentioned before also, even though they all follow the same principle, they all look very different. So if you think this art style really suits your game, you should give it a shot, you know. So there are 2 QR codes if you want to check out and wishlist a Bash on Steam, or if you want to connect with me on Twitter or the other Blue Sky platform. And yeah, thank you. Before we end, any questions? Yeah, give the mic to
Good afternoon. Good afternoon. My name is Dhruv, right?
It is afternoon, yeah.
Yes.
We are deciding if it's morning or afternoon, right?
Yes.
Yeah.
It's
Lunchtime.
lunchtime for everybody, yes. Uh, you mentioned, okay, one of the options for 3D at least was to create textures.
Mhm.
Your textures can be for 3D objects, or
Correct.
create a shader that pixelates your texture, right? Why can't we just use a full screen processing layer that pixelizes everything, and you have a mask for everything you don't want to apply a pixelation effect upon?
Okay, very good question. So a lot of games do this. I think the most popular one would be the first hike, if you've played it. So it renders everything at full resolution, and then just decreases the resolution on runtime and kind of uses a render texture to render everything on a very low scale. But that wouldn't qualify as HD2D, because the main purpose of HD2D is to have flat characters, right? In that case, if you're pixelating everything, then you're just using low-res 3D. That would be a PSX style that people like to call it, you know, PS1 era.
That's why I mentioned using a mask for everything. Like it's like you don't pixelate everything, but like it wouldn't having one shader for the entire screen just to pixelize everything, not that relevant, be more effective than having a shader run on every single object for pixelation of their textures.
So if you use pixelated textures, for example, for the base color, if you are creating the texture yourself, it would be very low res as well. So if you have a texture, for example, in my case, my wall textures are 128 by 128. So it's gonna take much less memory than if you were to use a 4K texture and then pixelating it on runtime. So it's a trade-off. You need to experiment with what you want to do with your game. So if you have relatively low-res textures like 256 or something, and if you have a full screen pass on the whole environment, that could work for you. Yeah. Thank you.
Awesome.
First off, I really like this art style. It's different.
Me too.
So my doubt is that, let's say we don't have 3D models, we have 2D backgrounds as well. Okay. Now can I use a 3D light, just the light, to get dynamic shadows for the 2D sprite?
Okay, depends on the engine, but
Unity, it's in Unity.
Okay, so URP now supports dynamic lights for Unity's 2D environments also. So it natively supports normal maps and all the other maps for all your 2D lights. So you could directly use that if you're using all 2D. Doesn't make sense for 3D lights in that case.
The thing is that if I use 2D lights,
So you're saying you need 3D shadows for your 2D objects?
yeah, and if I use 2D lights, as in general, it somehow it doesn't look as good as this. If I use just 2D lights for 2D sprites and backgrounds, but if I use, can I use a 3D light to get this kind of effect?
Your engine won't stop you. You'll have to experiment how that works. But 3D lights won't cast shadows on 2D sprites from other 2D sprites. So you're gonna have to create your own shader for that.
Okay. Can I talk to you?
Yeah, sure. I'll be outside for a
You
few
could take
minutes,
this
but I'm hungry
offline,
though. So
So the examples that you showed was mostly on like animation-based, sprite-based animations.
Correct.
I was wondering, what about spline-based animations that are like bones and deforming? Are there any pixelated shaders for those that we could use?
it would be easier, because if you have bones, you just deform the normal map as well, just like you deform your base color. And you could even draw that normal map, because you'll have to draw it only once if you're deforming your whole sprite with bones, right? And your artist will not hate you if you make them draw it once. Any other questions? They have a question.
Yeah, good afternoon. I just wanted to ask, so you mentioned the lighting and everything. What were you using, URP or HDRP for this?
I jumped from built-in to
Oh,
HDRP
SRP.
to URP,
Ah.
and the final verdict is URP is best.
And like, doesn't the issue of like, only 8 real-time lights can actually affect a single sprite or any material
Those are
texture
all
at a time?
configurable. So if you want more real-time lights, but you shouldn't have more than 8, that's disastrous.
Yeah.
So if you have more than 8, I'd suggest you have some kind of custom culling logic. So if your lights are not visible in your current view frame, just disable those light components as well. So there are free tools on that.
And one thing you mentioned that was intensive use of real-time lights, right?
Right.
So in this scenario, where would you use baked lights? Because we wouldn't want to have
So
everything
my
on.
environment uses mixed lights, where only the player character and all the sprites are gonna be having real-time shadows, and all the other static environment objects, they'll all have baked shadows.
Oh, okay.
Yeah.
That was all. Thank you.
Thank you. I think
We'll
they
take one
have-
more question.
they-
One more, and then I'll come back. I think we have time for
Yeah.
2 questions, right?
Yeah, I zoomed through all this stuff.
Yeah, hi. I am using this art style right now as of.
Good. Learn
Yeah.
from him. Yeah.
So my question was, in my game there is a scenic view. So, uh, in terms of your explanation there, you use shaders for the distance part of things, but
We
when
try
you're
to cut
imagining-
off things in the distance.
yeah,
because
yeah,
they don't-
basically hiding things which
Correct.
are not proper.
Right.
But in my game, it's like I want it to shine. I want the distant objects
Then
to shine.
you'd
more.
use the method that I showcased for until then, where they'd have a distance multiplier or distance divider
Yeah.
for things in the distance. So you'll have to pixelate them more
But
to make them stand
then,
out.
but then the image would look garbage. after
That
a
will
while.
depend on how
Yeah.
you make it.
Like
Honestly.
my solution was to go for like hand draw it completely the distant objects, but the PPU was different. So it created a kind of.
Have you tried using the same PPU as well for the distance?
Yeah, I have. I have.
Did that work?
It doesn't work.
Okay.
It doesn't work properly.
Okay.
So that's my question. Like, how do you do that? What will be your approach?
Okay, some games also, I think you guys know about Detective Dodson. So they use pixel sprites for all their characters, but they have totally high-res PBR materials for the whole 3D environment. So you could try something like that. Worked well for them. So yeah, you could.
Thank
try.
you.
Thank you. They were raising hands so many times.
Yeah. I'll have to
I
walk.
want to hear what he has to say.
Yeah, I think this will be the last question. And then, he'll be available here for a while, I hope.
Sorry.
So you'll be here after the talk as well. right?
Yeah, I'll be just outside until my stomach doesn't give up. Yeah, please. Yeah, thank you.
You can take it offline.
Okay. So I have firstly really pretty art style.
Thank you.
I wanted to ask what you used for modeling the backgrounds, which were 3D, and why didn't you go with voxel art? Because that's also like a form of 3D art, but which also has pixel
It comes
textures.
to a artistic decision, I guess. I don't like the way voxels make everything blocky. For example, I had curtains and everything in indoor rooms. I don't want them to be blocky, right? But yeah, a lot of games do use voxel. I'm forgetting a name, but you can use a tool called Blockbench. It's
Yeah,
made for voxel art.
The one
but
used by Minecraft.
Is it? Okay.
Yeah.
I guess so. But you can import high-res models in there also, and it really helps you texture them in a pixel art style.
Yeah.
So, yeah. Cool. Thank you.
Thank you.
Great question. I was waiting for that question.
Awesome. Really love the art style. I really like the tech behind it. Looking forward to the game. I think this was a very, informative talk. Really, thank you for the talk. Yeah. I think, yeah, if you have more doubts, he's here.